Assalamualaikum and greetings to all of you. So today I will continue chapter 4 part 1, that is vector valued function. Vector valued functions. Okay. So you see your notes. So introduction, scalar and vector. So scalar, a quantity only with its magnitude. For example, temperature, okay, let's say 25 degrees, or in Kelvin, speed, okay, mass or volume, okay. So a vector quantity is a quantity with its magnitude and its direction. So speed, let's say 100 km per hour. Volume, let's say 10 meter cube. Mass in kg, 30 kg. So vector, for example, vector, a quantity with its magnitude and its direction, that is velocity, 100 km per hour to the north. So we have direction here, okay, magnitude and its direction. So a vector valued function, or simply a vector function, is a function whose domain is a set of real numbers. Vector functions is a function whose domain is a set of real numbers and whose range is the set of vectors. Okay. Example 1. Okay. Domain of a vector function. Determine the domain of the following functions. Okay, A, RT equals to T 1 minus T to the power of inverse 1 in a vector form. Okay. Then we have B, RT cos T ln 4 minus T square root T plus 1. So now let's say r is the position vector, and then the function of rt is t 1 minus t to inverse 1, so this means same as ti plus 1 minus t 1j plus 0k. Okay, this is same as cos t I plus ln 4 minus t j plus square root t plus 1 k. Okay, now it's just the same meaning. Okay, we want to find the domain. So for the first one, okay, let's see what is the maximum or minimum value of the t. So we have t, only t, which means t can be anything, rational or irrational, real number, or anything. Okay, so t element of R. So your t can be anything. Your t is from negative infinity to infinity. To infinity. Okay. Okay, see the second one. 1 over 1 minus t. So 1 minus t inverse is same as 1 over 1 minus t. So to make this function always be defined, you have to make t minus 1 minus t must be always more than 0. Okay, which means t should be more than 1, or you can write like this: t minus 1 not equals 0, so t not equals to 1. Okay, in the j component. For I component, your domain is t negative infinity to infinity. You can write like this. But for j component, your domain will be t not equals to 1. Okay, so you can write domain t such that t element of R also t not equals to 1. Okay. Okay, B. So we have cos t, we have ln 4 minus t, square root t plus 1. Should try to separate. For I component, so you have to know how to find the domain. And then we have cos t. So cos t can be anything, right? Can be anything. So t R. Okay, t can be negative, can be positive. So any R. And then for j component, ln 4 minus t. So the domain will be 4 minus t more than 0. Remember not to put equal. So this will be t less than 4. Okay. Okay, k component square root t plus 1 must be more than or equals to 0. Okay, actually we just take the inside one, inside the square root. Inside the square root is t plus 1, so t must be more than -1. Okay, so if you merge all of this, you will get t less than -1 less than 4. Okay, this is your domain. Or you can write as above like this. Okay, it's up to you. Okay, next graph of a vector function. Graph of a vector function. Consider a particle moving through space during a time interval I. The coordinates are seen as a function. X equals to ft, y is equals to gt, and then z equals to ht, where the t element of I is the domain, time interval. Okay, then the points x, y, z is actually function of t, ht. Okay, the coordinates make up the curve in a space. Call them particles path. Make up a curve in a space called particles path. So this equation parameterized the curve. A curve in a space can also represent a vector function, vector form. Okay, so when t equals t naught, okay, at a particular point, I can write a position, particle's position vector as f t naught I plus g t naught j plus h t naught k. Okay, so RT is be a vector function, and suppose the initial point RT is an origin. The graph RT is the curve traced out by the terminal point of the vector RT as t varies over the domain set D. Okay, we will see examples so that you can understand. Okay, example 2. Okay, in your notes, let's say RT position vector, you have 3 minus t I plus 2j plus -4 plus 3t k for all t. Okay, so they ask you sketch the graph of the vector function. Sketch the graph of the vector function. Okay, so the solution. Okay, first you can separate this vector with x, this is y, and this is z. Okay, as shown here, you can separate your x equals to 3 minus t, and then your y equals to 2, and z equals to negative 4 plus 3t. Okay. From here, domain. Okay, the domain of this function is t always element of R. Okay, because we wanna choose t, so your t can be anything, because the function we do not have any square root or any reciprocal, so the t can be anything, is element of R, infinity. Okay, so what we will do is let's say I put this 1 and I put this 2 and 3, just denoting equation. So from 1, your t will be 3 minus x, and then I make it 4, and I just make 3 to the left and bring x to the right, or you plus t for both sides, okay? and minus x for both sides. Then I bring this t equals to 3 minus x into, I substitute this t 4 into 3, and then you will get z equals to negative 4 plus 3 minus x, and then you will get negative 4 plus 9 minus 3x, and then you have 5 minus 3x. Okay, now you have z equals to y equals to 2, and then you have z equals to 5 minus 3x. Okay, now we want to know the direction of t. Okay, as far as concerned, the t is element of R, so you can choose any value of t, okay, that refer to the domain of RT. Okay, you have to make sure these all domain are combined all, so that we can choose the correct value of t. So your domain of t will be, let's say I choose t0. Okay, so if I choose t0, r0 will be 3 minus 0i plus 2j. This is original equation of t, r, original r, and then I have negative 4 plus 0, negative 4 plus 3t, so 0. Okay, so I have 3, 2, negative 4, so I can write 3i plus 2j minus 4k also. Okay, just for simplicity. And then I would like to put t equals to 2. Okay, this is any value, you can put any value. Then you have r2. So from here, again from here, you just substitute t equals to 2. But this is 2j, you cannot do anything. So 3 minus 2i plus 2j plus negative 4 plus 3 times 2k. So you will end up with 1, 2, 2. Okay, and then t equals to 3. You will have r3 equals to 0, 2, 5. Okay, so this is the direction. We tried the direction of increasing t, t0, t1 and t2. Okay, t0, t2 and t3, sorry, t2 and t3. Okay, we just try. And now we have to sketch. So we have this function z equals to 5 minus 3x, we have z equals to 2. Sorry, y equals to 2. We have y equals to 2. Okay. First, we sketch 3D. Okay, we try to sketch this first. Actually, we can start from here, but I suggest you sketch this first. Okay. Okay, this is y, x, z, negative z, negative y, negative x. Okay. We have y equals to 2, which means here y2, x0, y0. So I just draw another one, y2, and then I just draw another axis in the same point, y equals to 2. Okay, so this is y equals to 2, and then what I have is z equals to 5 minus 3x. Okay, from here, from z equals to 5 minus 3x, if x is 0, z is 5. If x is 0, z is 5, which is here 5. Okay, and then if z is 0, five over 3, which means 1, 2 over 3. Okay, so which means if z is 0, x is 1.23. Okay, 1.23. So here, remember your y must be at 2, so somehow it's here. Okay, so from here you can notice that this is for z0 and this is for, sorry, this is for x0 and this is for z0, so you can join the point. Okay, you can join. Actually you can make longer. Okay, remember your y must be at 2, that's why I put here. So this is about 1 point something. Okay, here will be 1, 2 over 3. Okay, then now we can sketch for, we can plot a point for t0. T0 will be 3, 2, negative 4. 3 at x, let's say 1, 2, 3. 2 for y, which is here, and then 2 for y, sorry, here. Let's say 3, 2, negative 4. 1, 1, 2, 3. 2 is here, must be touch this point. 3, 2, negative. Okay, 1, 2, 3. 3, 2, 3, 2, negative 4 here. Okay, if you draw nicely, maybe you can get more nicer. So here will be your R0. Okay, check. Okay, 3 2 negative 2 3. So we have this line, this 2 3 2 negative 4, and then we have 1 2 2 at T2. 1 2 2 1 2. Okay, because this is at y equals to 2, and 2 upward. 1 2 2 1 2 until here, and 2. 1 2 2. How to see? 1 2 2. Okay, this is R2. Okay, and then lastly we have 0 to 5. 0 to 5. 0 at x, 2 at 0 to 5. So this is will be R3. Okay. So actually the trick is this all points R2, R0 and R3 is at the same line. Okay. This is just want to show this position vector is on the line. Okay, on the vector line. Okay. Position vector. So remember, position vector must be from the origin. So this is the first point. 1 2 3. So we have, okay, this one, and this one, we call them position vector. Okay, must be from 0 to this R, R0, R2 and R3. So when T increasing, you can see that when T is increased 0 to 2 to 3, the R also, RT is increases. As T increases, RT increases. Okay, we just want to draw the direction. So at the direction, they are moving upward. You want to show the direction, you want to see the direction. Okay, okay, this is for the first part. And then other example, sketch the following vector function if RT equals to 3 sine Ti sine 3 T I minus 3 cos Tj plus 2k. Okay, okay, so as usual, the same thing, the same concept. Separate them into x, y and z. So x equals to 3 sine t. Okay, y equals to negative 3 cos t, z equals to 2. Okay, for your syllabus, they always have we have one constant. Okay, either one of the axis, one of the vector must be a constant. So from here, the domain of this RT will be T such that T element of real number. Okay, always a real number. Okay, so for this question, we have to use, you have to find the domain, and then we have to use x squared plus y squared equals to r squared formula. Easy. Circle formula. So if you put here like this, you just substitute what is the x, y and z. 3 squared sine squared t plus negative 9 cos squared t equals to 9, and then sine squared t plus cos squared t, that equals to 1. Okay, 9 times 1 is 9. So we have x squared plus y squared equals to 9. So remember, your z is equals to 2. So you can sketch, no problem. Okay, but at z equals to 2. So when you sketch the 3D, so we have z2 here, and then we have okay, and then your radius is plus minus 3. Yeah? So here should be 3, and here should be negative 3. Okay, we already draw the function. Now we have to choose the direction of the increasing t. So the 3 should be from 0 to pi. So please use 0 to 2 pi. Please use radian for this question. Okay, for this kind of problem, please use radian. So if I put t, let's say I start with 0, so t0, your RT will be 3 sine 0 I, or I just put like this, I just put in another form without I, 3 sine 0 minus or comma 3 cos 0. I think we have minus, okay, minus, and then we have 2k, so just 2. So this is 0, negative 3, 2. Okay, and then we have t equals to, let's say I choose pi over 2. Okay, or I just choose pi. So the pi will be r pi 3 sine pi negative 3 cos pi 2. So you will have 0, cos pi will be negative 1, negative 1 times negative 3 will be 3, 2, and then t equals to 2 pi So r2 pi will be 0, cos 2 pi will be 1, right? Cos 2 pi will be 1, so negative 3, 2. Okay, so now try to find the direction. 0, negative 3, 2. 0, negative 3, 2. 0, negative 3, 2. So it is here. So let's say I put this r0 and then r pi. R pi will be 0, 3, 2. 0, 3, 2. This here. And then r2 pi also here. 0, negative 3, 2. It is same as here. Okay, so you can see that the direction moves from here to here. So your direction will be like this, because I start with 0, 0, r0, r pi, and then r2 pi is here. So it will be like this. Okay, and then the position vector will be from origin. You just add. Okay, that's all. You can choose 3 points or 2 points. Okay, so usually we use 3 points. Okay, we're done with this. So there is an example in your notes. Past test 2019. Past test 209010 sem 1 semester 1. So please do it. Okay, this is your homework. Okay, okay, next will be vector functions operation. Vector functions operations. Okay, for vector function we can use any letter, for example RT, or somehow they use RT, something like that, R cap, FT, or F cap T. So just want to show that there is a vector. Okay, actually this R is R bold, or sometimes we can write as R arrow at the above. Okay, so for the direction of a vector we can also use the symbol, say I, J, K. This is like a tidal. Okay, so let f and g be a vector function. So I put like f and g. Let's say I put f like this, so you can use f also, f like this. F and g a vector function. For vector functions of the real variable t, and let ft be a scalar function. Ft is a scalar function. Big F and big G will be the scalar function. So f plus g t will be ft plus gt. Small f times with f t will be ft times with t, and then f cross we can say 1, 2, 3 cross g t will be f t cross gt. F dot g t will be ft dot gt. Okay, so we see some example. Example 4. Let f 2rti minus 5j plus t squared k. Okay, g will be 1 minus ti plus 1 over tk. Okay, and then h, vector h will be sine ti plus e to the power of tj. Okay, this is 0j and then this is 0k. Okay, fine. T squared F times with ft minus 3ht. Okay, this is nothing, this is just t squared times with the f, given f, that is 2ti minus 5j plus t squared k minus 3ht. ht will be sine ti, you have to put the bracket, plus e to the power of tj. So you simplify this, you will get 2t cube minus 3 sine t, I with I, j with j, k with k, and plus minus 5t squared minus 3etj, okay, j with j, and then lastly plus t to the power of 4k. Okay, so second one, they ask you to find f dot g. So dot mean scalar, okay, divergent. Okay, dot mean scalar. Okay, so usually we put a big dot to represent the vector multiplication and small dot for a scalar multiplication, normal one. Okay, like 3.5 is 15. Okay, okay, this is normal one, so this is big one, just to indicate the difference. So write first what is ft, so you can find it from your notes also. So this is f is 2ti minus 5j plus t squared k dot with 1 minus g dot g. G is 1 minus ti plus 1 over dk. Okay, remember for scalar, I times with I, j times with j. Okay, so I times with I and k with k. Okay, and we have 0j, so you say I add 0j, so j will times with 0j. Okay, negative 5j will times 0j, so it is 2t times with 1 minus t, or you can put dot, plus, okay, you will end up with a scalar because it's a dot product, j with j, negative 5 times 0, or you can put dot, or you can put bracket, plus t squared times with 1 over t. So this is 2 t minus 2t squared plus 0 plus t. This is 3t minus 2t squared. Okay. Okay, next. Number 3, cross. Ft cross gt. Cross product will give you a vector. Dot product will give you a scalar. So this is a scalar. So 2, 3. I just write a different way without ijk. Minus 5 t squared. Okay. Cross with sine t I e t j 0k. Okay, nothing means 0. So remember, we have to do like this. I j k 2t negative 5j t squared, and another one will be sine t e t 0. So to do this, remember plus minus plus. Okay, remember this is plus I minus j plus k. Okay, remember this. So when you do different, this will be, so you close the first one. Okay, you close the first one. For I, you close it. Let me show. You close the first one and then you find the determinant. Okay, let me see. Okay, use the highlight. So I will close this for I. Close this for I. So and then I find this determinant. Okay, I will get negative 5 times with 0. Determinant must be minus a b c d a d minus b c. So minus e t t squared, and then this is will be I for I. Next, okay, for j, remember start with plus and then I have minus j. So your j, you have to close jj and then find the determinant. So the determinant will be 2t times 0 minus t squared times with sine t. Okay, and then lastly, remember we have plus minus plus k. So when you do like this, you have to close the k. We'll find the determinant, find the position. So 2t times with et minus 5 times with sine t. Okay, AD minus BC. Let's say ABCD, AD minus BC. So you will end up with negative t squared, and simplify et I plus t squared sine tj plus 2t et plus 5 sine t all together. Okay. Okay. Number 4, ft dot h ft cross gt. Okay, in this case you have to do this first. Okay, remember that if you start from left, ft dot ht will be a scalar. A scalar cannot times with a vector. Okay, must be a vector times with a vector, cross with a vector, sorry. So if you do this cross first, you will get a vector. So vector dot with a vector, okay, because all these are the vector. Cannot 0 times ft, but 0 vector time f vector can. Okay, so remember this. So you choose the other color. So I think you can do by your own. H cross G, H cross with G, H cross with G, you will get E t over t I minus sine t over t J plus et minus et here times y minus t k. Okay, then we have to dot ft dot, you will get 2 et plus 5 sine t over t minus t squared et 1 minus t. So please check. Okay, next. So we stop here. In the next class we will learn differentiation and integration of vectors. Okay, see you.